Okay, so we start this section. Yeah, so because this is going to be reactions of arenes. Yeah, and for reactions of arenes, we learn about two things. Yeah, which is going to be benzene, and going to be we learn also about methyl benzene. So what is benzene? What is methyl benzene? Okay, by now you should know that benzene, they look like this. Okay, and methyl benzene, they look like this. Okay, so the history of this. Okay, and then the what is going to be why. Okay, we don't actually use the previous three double bonds, okay, for benzene to represent the structure and so on. You should know, yeah, which is going to be, okay, there are two evidences that they found. One is going to be the carbon-carbon bond length. Okay, they found out that it's going to be different. Okay, then it's not, okay, the carbon-carbon double bond, okay, is shorter than carbon-carbon single bond. But when it comes to benzene, they find it's somewhere in the between. Yeah, so if you follow the double bond, okay, what happened? Okay, you are going to have a distorted shape. Okay, but we know that, okay, benzene is going to be planar, symmetrical, so we cannot actually use that method of drawing. And number two, they found out that, okay, because of the presence of the benzene ring, yeah, they found out that the structure is going to be very stable, so they do not undergo, okay, electrophilic addition easily. Yeah, so they do not undergo electrophilic addition easily, like normally for alkene they will undergo electrophilic addition at room temperature and immediately. But in this case, okay, benzene, because of the aromatic stabilization, so I'll write down because of the aromatic stabilization, so the reaction, okay, will actually will not be that favored. Okay, stabilization will not be favored. Okay, instead, okay, they are going to favor electrophilic substitution. Yeah, but in our syllabus, yes, we do actually have the reaction electrophilic addition, but under harsher condition, hydrogenation. Yeah, later we'll go into that. Okay, so therefore, knowing all this about benzene, yeah, we are going to actually learn about the reactions. Yeah, so the reactions, okay, for let's actually look at overall. Yeah, so reaction, rather than saying reactions of benzene, yeah, so we'll just say reactions of arenes. Yeah, so the reactions of arenes, okay, we will actually start. Okay, we will start. Okay, of course, the first reaction supposed to be electrophilic substitution reaction. Okay, so this electrophilic substitution reaction we have learned. Okay, one, okay, is going to be the reaction with Br2. Okay, and we learn about reaction with Cl2. Okay, we have learned about with NO2 plus. Later I'll just put the condition. Yeah, so you are going to get the nitrobenzene. Yeah, and I think that's all. Yeah, for electrophilic substitution. Yeah, for involving benzene. Yeah, benzene and so on. There is another one. Sorry. Okay, so there is another one which is going to be Friedel-Crafts reaction. Okay, that is also going to be this alkylation and acylation. Okay, they are going to be considered to be, okay, to be electrophilic substitution. So yesterday when I did the TikTok video, I think I forgot about Friedel-Crafts reaction. Yeah. So anyway, yeah, when you continue, okay, we do have, okay, apart from electrophilic substitution, okay, we do have other reaction which is going to be free radical substitution. But do remember, free radical substitution, they are going to happen not for benzene. Okay, benzene will not undergo free radical substitution. Okay, but it will affect alkyl benzene. Okay, So it will affect the one that is benzene that is attached to side chain, the alkyl side chain. Yeah. So free radical substitution. And if you move on, okay, later we'll go one by one. Okay, if you move on, we also learned about oxidation. Okay, so benzene, okay, they do not undergo oxidation. Do remember that. Okay, benzene, no oxidation. Okay, but this one will affect alkyl benzene. Okay, alkyl benzene, they will actually undergo oxidation. Okay, and if you go for number 4, okay, apart from oxidation, okay, so electrophilic substitution, free radical substitution, oxidation, and the last one should be the electrophilic addition. Okay, electrophilic addition, okay, the one that is required is the hydrogenation. So this is the least favored, yeah. So which is going to be normally must have under harsher condition. Okay. So this, okay, will affect, okay, this one rather than say it will affect benzene only, yeah, it can also affect alkyl benzene, yeah. So please take note, okay, the moment that they have the uh, benzene ring, yeah, so they can actually undergo hydrogenation. Okay, later I will actually give you some examples that are unconventional as well, so that you can also clearly see. Yeah, so the one that I taught you, everything is going to be straightforward earlier. Okay, but now maybe now we will go deeper a bit. Yeah, so if you look at the reactions, yeah, so let's actually look at one by one. Now reaction with Br2. Okay, the reaction of Br2 and reaction with Cl2. Okay, these two, okay, will require halogen carrier. Okay, they require halogen carriers. Okay, so the halogen carriers is AlBr3 or AlCl3. Okay, so if let's say for example I want to actually react, okay, with let's say this is going to be my benzene, yeah, and I want to react, okay, with the Br2, yeah, but now, okay, I told you, okay, let's actually look into something that is unconventional, yeah. Can this reaction happen, okay, let's say for example, okay, I think this one has been already discussed over in the syllabus, but it's okay. Okay, we'll just do the normal one. Yeah. So let's say I'm going to react with Cl2. Okay, what is going to be the mechanism of the reaction? So first thing, okay, you should know that, okay, if I have AlCl3, when I react with Cl and Cl, the AlCl3 is going to polarize the Cl, so they are going to actually become delta negative, delta positive. This one will come over here. You are going to get AlCl4 minus, yeah, and then you are going to get Cl plus. Okay, so the next is going to be the Cl plus here. Okay, this one will come over here. You are going to get something like this. Okay, H and Cl. This is going to come over here, and you are going to get chlorobenzene. Okay, plus H plus, that H plus can join with the AlCl4 and to give you HCl and AlCl3. Yep. So the mechanism of the reaction you must know. Yeah, you must know. Okay, the same thing. Okay, the same thing if you have, okay, let's say for example, if you have methyl benzene, yeah, if you have methyl benzene, okay, please remember, okay, if you are going to actually bring in the halogen, yeah, methyl group, okay, is going to activate position 246. Okay, they are going to activate position 246. So if let's say for example, if I have, okay, a methyl benzene, okay, a methyl benzene CH3, and I react, let's say, with Br2, okay, what do I expect? okay, you are going to have, okay, a mixture. Yeah, you're going to get a mixture, which is going to be, okay, this one is very important. Okay, you are going to get, okay, the at position number 2, and then you will have, okay, a methyl benzene at position number 4. Okay, 6 no need. Okay, it's the same as earlier. Okay, and then HBr. Okay, it's not balanced. Okay, if you want to balance, okay, so this one should be 2. Okay, so this one is going to be 2. Okay, so this is going to be under the under, let's say, normal condition. Yeah, normal condition with the presence of AlBr3. Okay, so if, let's say, I am going to do this reaction, okay, and I am going to use excess of Br2. Okay, if I'm going to use excess of Br2, then the reaction is going to be different. Yeah, so if you do that, okay, you are going to have different products. Okay, so if you have excess, okay, let me. If you have excess, okay, for example, like this, CH3, okay, Br2, now Br2 is going to be in excess. So AlBr3, you are going to get CH3, Br will come over here, okay, and Br will go here. You will have this mixture, CH3, Br will come over here, Br will come over here, and you will have another mixture where CH3, Br will come over here, Br will come over here, Br will come over here, plus HBr. Okay, this one is 3. So you need, okay, let me see, it's not 3. How many H is given out? 1, 2, 3, 4, 5, 6, 7, 7, 8. So 7. So how many Br? 14 Br. So I need to have 7. Okay. So this one is balanced. Okay. So just to check, yeah. Davis, can you follow up to here?
Yeah.
Yeah. So all this, okay, we have learned, okay, under electrophilic substitution, okay, Br2 and Cl2. Now, when it comes to NO2, it's still the same. Yeah. So when it comes to NO2, it's still the same. So I'll just write down for you the mechanism of the reaction. But yeah, so do remember this NO2, yeah, they are going to be prepared. Okay. The electrophile, you need to prepare with concentrated H2SO4 and concentrated HNO3, yeah, at 55 degrees Celsius. Yeah, let's actually focus directly to the point, because in your syllabus they say 20 to 60. Yeah, so I'm just using 55. So if you have this, okay, you need to know how to write the equation H2SO4 plus HNO3. You are going to get NO2 plus H3O plus and HSO4 minus. Okay, so this is the electrophile. Okay, once you have the benzene and you have the electrophile, okay, so what is going to happen? This one will come over here. You are going to get like this, HNO2. Then this one will come over here. You are going to get nitrobenzene, okay, plus H plus. Okay, this nitrobenzene can further nitrate it. Yeah. So this further nitration, yeah, further nitration. Normally they didn't say, if they didn't say further nitrated, you just put the nitrobenzene like this. But okay, if they say the reaction, yeah, will undergo further nitration, yeah, or left it left for a period of time and so on, what do we expect? Okay, nitro is going to be group 1, 3, and 5 activating. Nitro is going to be electron withdrawing group. Yeah, so they are going to activate. Okay, they will slowly have further substitution. The NO2, this is group number 1. Yeah, so group number 3 will be this one. Yeah, and okay, this one NO, and then there will be further nitration where you are going to have, okay, let me draw NO2 here, NO2 here, NO2 here. Okay, so you will have, okay, further substitutions. Yeah, so I'll just put further substitutions. Okay, so that one done. This one done, this one done, this one done. Now left with Friedel-Crafts reaction. Yeah, for Friedel-Crafts reaction, yeah, we have learned and alkylation and acylation. Yeah, so I will actually show you, okay, directly here. Okay, I'll separate. Okay, and then I'll show you, okay, alkylation and acylation. Now for alkylation, okay, you are going to actually add alkyl groups, okay, into the benzene. Okay, so for alkylation and acylation, you still need to have, okay, the, because you're directly substituting into the ring. So you still need to have the catalyst, you still need to have the halogen carrier. Yeah. So this reaction, okay, let's say for example, I have benzene, and I want to actually substitute the benzene. Let's say, for example, let's go for something unusual, C3H7. Okay, and then I put the Cl over there. And then I am going to use KAlCl3. What I am going to get, I am going to get C3H7 over there, and I am going to get ACl. Okay. So if you have acylation, yeah, you are going to have, let's say, for example, let's say I use a similar example, okay, but C double bond O, okay, here can be Cl or Br, okay, so let's say here I put the Cl, yeah, just still the same, Cl, and the alkyl groups I put this side, maybe I put C3H7, okay. So similar, okay, they are going to require AlCl3, okay, and they are going to give you the product C double bond O, and then you will have C3H7, and you will get HCl. Yeah, this is going to be the reactions that is going to happen. Okay, of course, we don't actually stop over there. Yeah, we need to know how to write the mechanism of the reaction. Yeah, the mechanism of the reaction, okay, can be written, yeah, similar like what we have learned. Yeah, so it's C3H7. Okay, you have Cl. Then you react with the AlCl3. Okay, this Cl itself, no need AlCl3. The Cl itself will become polarized, okay, because it's going to be more electronegative, so delta negative, delta positive. You are going to actually react with this, you will get AlCl4, okay, minus, and then you will have C3H7 plus, okay. So the next step is going to be quite simple. You just put the benzene, okay, and you react with C3H7, okay, this is going to be plus, okay. So this one will come over here, okay, and you will get incomplete over here. You will have H and then C3H7. Next is going to be this thing will go in, okay, to give you, okay, C3H7 plus H plus, okay. So this one, you see, everything is the same, okay, even though Yeah, I'm taking time. Yeah, but I think it's the same. Yeah, very much similar. Yeah. So with this explanation, slow, okay, and then repetition and so on, I hope you can actually follow. Yeah. So here, okay, I will take, okay, I'll put C3H7, okay, C double bond O Cl. Okay, I will react with the AlCl3. Okay, so similar. This one is going to be delta negative, delta positive. Okay, so this one will go here. So you will have AlCl4 minus, and here you will have C double bond O C3H7, and this is plus. Okay, so this is going to be the electrophile. So you will have the benzene, okay, and then you will have the electrophile, okay, and then this one will come over here. You will have the U H C double bond O C3H7, okay, and this is not stable. Okay, they will bring the electron pair inside, okay, and they are going to give you this product, C double bond O C3H7 plus H plus. Okay, so acylation and alkylation, okay, done. Okay, so this is also done. Okay, Jordan, so far okay?
Yes, sir.
Okay, so now, okay, we go into free radical substitution. Yeah, under free radical substitution, yeah, the benzene doesn't go free radical substitution. Yeah, so only alkyl benzenes will go free radical substitution. So let's actually select something we never done before. Maybe we select, okay, like what we did just now. Maybe we select C3H7. Yeah, C3H7 as our example. Okay, so do remember, okay, this one must be boiling condition. Okay, the condition must be boiling, and with the presence of UV light. Yeah, must have presence of UV light or sunlight. Okay, so the reaction, let's say now I'm going to actually react with Br2 or Cl2, doesn't matter. Yeah, what do we expect? Okay, we are expecting that, okay, one of the hydrogen is going to be, you will have C3H H6, okay, and then you will have Br, okay, and then plus HBr, okay, something like this. Okay, so this is what we expect. Yeah, but now, okay, I still want to actually show. Yeah, but anyway, if let's say this reaction continues, yeah, continues and until all the hydrogen substituted, okay, so what we will have is going to be, you are going to get, I'll just draw, you will get C3 H7, right? So now it will become Br7. Yeah, this is what we are going to have. Yeah, if let's say the reaction completely happened. Yeah, but what I want to show you today, okay, is going to be, I want to show you, okay, so let's say, for example, in a simple sense, yeah, so if I have a methyl benzene, okay, if I have a methyl benzene and I am going to react with Cl2, okay, under the presence of UV light, and this is boiling. Okay, we know, let's say, let's focus on single substitution first. Yeah, so CH2Cl, then I have HCl. Let's say now, okay, they ask you to write down the mechanism of the reaction. This one I will repeat to the one that we studied under alkanes. Yeah, so they can ask you the mechanism of the reaction. So now those who have forgotten, yeah, please remember and please try to actually follow. There will be initiation reaction. Okay, initiation, yeah. Initiation reaction. Okay, for initiation reaction, okay, you are going to have, okay, the Cl2, okay, the Cl2, they are going to be with the presence of UV light, okay, there is going to be homolytic fission will happen, okay, homolytic fission will happen. So you are going to get the Cl dot and Cl dot, okay, it means free radicals are being formed. Okay, the next step, okay, is going to be your propagation. Your propagation step, yeah. Remember, neutral or something that is complete, they will be attacked by something that is not complete, yeah. So it means something complete with free radical, yeah. So it's always like that under propagation. So the one complete over here is the methyl benzene. So I'll just draw methyl benzene here. Okay, methyl benzene is going to be attacked by what? Not Cl2, yeah, will be attacked by free radical. And what will happen? Okay, the hydrogen from there, yeah, you are going to get, okay, this CH2. The hydrogen will be left, yeah, H2. So this is going to become a new free radical, okay, and you will have HCl. The next step of the propagation is going to be you take the new free radical that you have formed, CH2 dot. You react, remember, free radical complete with free radical. So now you have free radical, you react with complete, so Cl2. Okay, and what will happen? You are going to get CH2 Cl, okay, left with free radical of Cl. So there will be always free radicals being formed. Yeah, that's why it's called propagation. Okay, finally, because it's a single substituted, I'm not going to actually do everything. Yeah, so this one, okay, at the end, there will be termination step. Termination step, okay, can be any free radical joined together. You will get Cl2. Yeah, or, okay, in this reaction, we know that CH2 dot can also join with the Cl dot to give you CH2Cl. Okay, or you can also have CH2 dot joining with CH2 dot. Yeah, so you will get something quite amazing. Yeah, so something like this. C join with another C, and then these two will have H, 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 H. This is application, yeah. So I hope you can follow, yeah. So this is going to be, okay, what we are going to get, yeah. So can do. All right, I admit the can do. Is it okay? Okay, this one, let me ask Clienta, is it okay? Can follow? Ilan, okay? Right. Yes. Now, let's go to oxidation. Yeah. So oxidation, okay, benzene will not undergo oxidation. So alkyl benzene do undergo oxidation. Yeah. So alkyl benzene, when they undergo oxidation, yeah. So you need to know, okay, that, okay, they will whatever attached to that benzene, okay, they are going to be oxidized, okay, to benzoic acid. So let's use C3H7. Okay, C3H7, I am going to oxidize, okay, with what? This is important. Okay, it must be hot KMnO7, okay, hot potassium manganate, okay, but must be alkaline first, then acidified with dilute H2SO4. Okay, so it's going to be slightly different. Okay, okay, whatever it is, okay, they are going to give you benzoic acid, COOH. Okay, so the product, okay, I have mentioned to you, if you have more carbon and suddenly there is lacking of carbon, there must be carbon dioxide. Yeah, there must be carbon dioxide. And do remember there will be, okay, water will be formed. Okay, but let's actually figure out whether we can balance this up or not. Yeah, so let's actually try to balance this. Okay, so when I try to balance this, okay, we know that earlier there is hydrogen there. Okay, I still have hydrogen there, so no problem with that. Okay, the only thing that is coming out over here is going to be 2 carbon. So 2 carbon is not being used. Okay, hydrogen 1 is used, so you have 6 hydrogen. Okay, 6 hydrogen not being used. This one I don't know how many oxygen. Yeah, so I just leave it over there. Okay, but here when I look at the number of oxygen here, I have 2. Yeah, I definitely need 2 carbon here. Okay, whether you like it or not. Yeah, you need to have the 2 carbon over there because I need to have 3 carbon. Yeah, so before I count the number of oxygen, I need to put the 2 over there. Okay, and then okay, left with trying to balance the hydrogen. Yeah, before we balance the oxygen. So when you look at the number of hydrogen, okay, that is going to be given off. Yeah, I can see that, okay, I have 1, sorry, not 1. The one here is going to be, I used up, yeah, sorry, this one, 6H is not being used, yeah, not being used. So of course, you need to have 6 hydrogen over here, yeah, 6 hydrogen over here. So the only way is to put 3, yeah, 3. Okay, so that I get the 6, I use up the 6. Okay, so I already used up this 2 carbon also. Yeah, the remaining. The last thing that you need to balance is the oxygen. Yeah, so I have 3 oxygen over there. Okay, I have 4 oxygen over here, and I have 2 oxygen over here. That makes a total of 9. Okay, so you need 9 oxygen. What you need to do is just put 9. Simple, right? Okay, so this is how I balance. Okay, how I balance. Okay, so this is something that maybe you need to also focus on balancing, because when they ask you to balance the equation, yeah, you need to know how to balance. Okay, so this is going to be, okay, oxidation reaction. The important thing is must be boiling lah. Yeah, must be boiling. And another important thing is, okay, you must have, okay, benzoic acid. You need to identify, okay, if you have extra carbon, there must be carbon dioxide. Yeah, there must be carbon dioxide. They didn't specify in the syllabus, okay, but it's a common sense. Yeah, oxidation, yeah, they will actually give you carbon dioxide. Okay, if not, where the extra carbon disappear? Yeah, they don't simply disappear. Yeah, so that is going to be how you need to write the equation. Yeah. Finally, yeah, we'll go into this electrophilic addition reaction. Yeah, this is for benzene only. Yeah, so today I think we'll just not enter carboxylic acid. Yeah, so we will actually go this, and then after this I'm going to go into phenol. Yeah, so let's actually finish up this chapter. Yeah, next week we start fresh. Yeah, so electrophilic addition, yeah, is going to be, you are going to have hydrogenation. Yeah, must be in harsher condition. Why? Okay, because electrophilic addition is not favored. Yeah, because, okay, the aromatic stabilization, okay, the aromatic stabilization will not favor, okay, the addition reaction. They will favor electrophilic substitution. Okay, therefore, okay, if you really want hydrogenation, okay, so if you have, let's say, a benzene and I'm reacting with hydrogen, okay, we will assume, I think the easier way to look at it is going to look at it in form of double bond. Yeah, so if let's say you have like this, okay, and I am reacting with hydrogen, okay, so what will happen? The double bond will ester will be broken, so you will have additional, okay, 2 hydrogen coming in over there. this double bond is broken, you will have additional 2 hydrogen come over here. Double bond broken, additional 2 hydrogen will come over here. Each of the carbon, they used to have 1 hydrogen. Yeah. So I will actually put the previous hydrogen over there. They used to have 1 hydrogen. So now you can see that each carbon automatically have 2 hydrogen each. Yeah. So when you draw, okay, it will be, you are going to get, okay, something like this, okay, and then no need to you just put the hydrogen, okay, hydrogen, okay, like this. Actually, if you don't show also, it's fine, because carbon and hydrogen normally will not be shown. Okay, so this one, if they show, yeah, so basically if I erase, okay, this one just to make you see, yeah, but if I erase, okay, it's fine to draw like this. Okay, and then plus, okay, what you get, you don't have anything, so just draw. Yeah, so you are going to get, okay, how many hydrogen gas is going to be used? So 3 molecules, yeah, 3 molecules, 6 atoms, yeah, will be used. So you are going to get benzene, okay, is going to be hydrogenated to become cyclohexane. Okay, cyclohexane is C6H12. Yeah, so this is going to be done, okay, with the presence of nickel and platinum. Normally at under electrophilic addition, we use 140 for alkene, but this one should be high pressure or high pressure and high temperature. Okay, so if you want to give a value to it, I think maybe you can give 180 or something like that. Yeah, but in your syllabus they say high temperature only, they didn't give a value. Yeah, so you just say high temperature is fine. Yeah, nickel and platinum. Okay, but okay, I also want you to explore, okay, certain things that are not mentioned in your syllabus, but they can ask. Okay, for example, okay, for example, if I have methyl benzene, okay, so let me ask Jordan, can methyl benzene undergo hydrogenation, Jordan? Okay, they can. Okay, they can. Okay, so you see, if I represent this, okay, in terms of let's say like this is CH3. Okay, so if I represent this over here, okay, so if I put over there, it means that there is no hydrogen near to CH3. Yeah, there is only the carbon is bonded directly to CH3. Yeah, so I mean here, yeah, this carbon is only bonded to CH3. There is no hydrogen. Yeah, so now what happens? Okay, the hydrogen will come here. The hydrogen, okay, there was 1 hydrogen each here. So now you are introducing, okay, new hydrogen here, 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 new hydrogen here. Okay, so if I put it simply, yeah, if I put 3H2, okay, I am going to get CH3. Okay, the rest are all having hydrogen. Yeah, the rest have all hydrogen. There is no no need to represent a circle over there. Yeah, but if you want to know what is going to be the structure, yeah, basically the structure is going to be, if you want to count also fine. Yeah, so this one is C6. Yeah, how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, and then CH3. Let me see. Let me count again. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, correct. So you will get this C6, H11, CH3. Okay. So this one, okay, also platinum, nickel, high temperature. So don't actually be limited to what you learned only. Yeah, it can be applied, okay, for whatever things that you I didn't teach. Yeah. So now it's more towards, okay, you are applying your knowledge into some other additional context. Yeah, you must not be limited. Yeah, so you must actually learn all this. Okay, now, okay, let's actually move on to phenol. Okay, so phenol, okay, is going to be, I think, should be very fresh in your memory. Yeah, so no need to actually go very slow. Yeah, phenol. Okay, phenol, I told you. Okay, phenol is like the hottest girl, okay, or the hottest guy in the class. Yeah. Okay, which is, okay, if you want, okay, like for example, okay, if you are a guy or girl, okay, let's say this is the girl, okay, and then, okay, you see this one guy, okay, yeah, okay, so then you are attracted. Yeah, so this is going to be the electrophile. Okay, you're attracted. Okay, but okay, then you have another guy who's very tall, okay, very athletic, very cute, like Korean model or something like that. Then the level of attraction is going to be greater. Okay, the level of attraction is greater. The level of attraction may be not so great. Okay, maybe you go and ask your another friend to help to, you know, talk to the person. Yeah, but okay, in this case, okay, this one, no need to have any third person. Yeah, want to approach directly. Okay, the same thing, okay, will apply, okay, to this situation, which is I'm talking about. This is methyl benzene. Okay, methyl benzene, okay, is going to actually give, okay, the methyl group is electron donating. Yeah, so it is going to make the charge density or the pi bonding to be more available for electrophile. Yeah, but still, okay, you require the halogen carrier. You still require halogen carriers. Okay, so the reaction still fast, more as the electrophile can go easier, but still not so great. Yeah, because of still there is overlapping. Yeah, of the lone pair with the pi bonding. Yeah, so all this will happen, but the degree of overlapping, okay, of the electrons, okay, the lone pair to the pi bonding for phenol is more. Yeah, so that makes, okay, the electron density to be more, so that makes phenol to become more hot. Yeah, so in that sense, okay, you do not need, okay, no need, okay, no need halogen carrier, and even certain conditions they will bypass. Okay, they will bypass certain condition. Okay, bypass certain condition. Okay, so we will actually look into reactions of phenol. Yeah, so first thing is, okay, you need to know about, okay, phenol. Okay, is a weak acid. Okay, why phenol is a weak acid? Okay, you need to know that phenol, okay, they are going to have C6H5OH. They are partially dissociated to give you C6H5O minus plus H plus, which is, this is a phenoxide. Now, this phenoxide, okay, is going to be, when you look at the benzene ring, okay, this is O minus, okay, the lone pair of electrons, okay, they are going to be able to overlap with the benzene ring. Yeah, so when they overlap, okay, that is going to make this phenoxide ion to be more stable. There are two ways to tell. Yeah, one is more stable, okay, making it, yeah, making the reaction to go more towards forming the phenoxide. Yeah, or there is another way to look at it where, okay, this is going to be the overlapping of the electron is going to make the charge, the negative charge to be spread. Yeah, when the charge is spread, okay, the the negative, okay, is not uh, how, yeah, it's not concentrated. Okay, it's not concentrated to the to O atom. Okay, so if it is not concentrated over there, it means that the charge is less over here. Okay, at that O. So that is going to make that these two negative and positive supposed to be attracted. If you have less negative, yeah, they are not going to happen. Yeah, the reaction between them is not going to happen. So therefore, the backward reaction is not going to be favored. Okay, to form ethanol, to form the phenol is not going to be favored. So they are also going to actually strengthen, yeah, this one to form more over here. In that process, okay, you are going to increase the H plus. Okay, so in this case, you are going to have a better weak acid, yeah, compared to ethanol, okay, and water. Yeah, so for ethanol, it's the other way around. Yeah, so ethanol is C2H5OH. Okay, they are going to give you C2H5O minus and H plus. Okay, for ethanol, this is going to be ethoxide ion. They are, okay, the C2H5 is going to be electron donating group. Yeah, so when they donate electron, the charge density of the negative charge at O is more. Okay, when it's more, the reaction is going to be favored. Okay, when it is favored, okay, so you are going to have more reaction to form the ethanol. Okay, if you have more reaction to form the ethanol, this one is not favored. Yeah, so if it is not favored, okay, it means that the concentration of H plus is going to be decreased. Yeah, so if that concentration is decreased, then it's going to be less acidic. Yeah, so that explains, okay, why phenol, okay, phenol is more acidic than water, okay, and why ethanol is going to be less acidic. Yeah, so that is going to be the explanation, yeah, about phenol. But when it comes to reaction, this one will affect. Okay, this one will really affect the reaction, because you know that phenol, okay, they will react as though they are like weak acid, like carboxylic acid and so on. Yeah, so like for example, they can react with sodium, they can react with sodium hydroxide. But just now we have learned that ethanol is not a very good weak acid. Yeah, so they can react with sodium, but when you react with sodium hydroxide, no reaction. Yeah, so why? Because they are not a very good weak acid. Yeah, so they don't have any reaction. Yeah, but for sodium, yes. Okay, so let's actually look into the reaction of phenol. Okay, reaction of phenol. So you have one, you have two. Yeah, reaction with Na, reaction with NaOH. Okay, so for reaction with Na and NaOH, okay, so I'll just go faster a bit. Yeah, so you have OH. Okay, you react with Na, you are going to get the sodium phenoxide, O minus and A plus, and then you will have hydrogen gas. Okay, and if you have the reaction of phenol, okay, with sodium hydroxide, okay, you are going to get, okay, this is all neutralization reaction. Yeah, okay, so this is O minus and A plus, and then you will have H2O. Yeah, so you are going to get this reaction. Yeah, now for the third reaction, okay, this is going to be something extra. Yeah, which is going to be the third reaction is a bit complicated. Okay, this one, third reaction, is part of diazotization reaction, which is going to be part of the coupling reaction. Yeah, so I hope you remember. Okay, this one, okay, is I taught you because we need to know about this, because they will ask you about how to form phenol. Yeah, how do you get phenol in the first place? Yeah, so how to get phenol in the first place is going to be the first part of the diazotization reaction, because phenol is being formed, okay, from let me actually make it here. Okay, phenol, okay, is made, okay, from first part of diazotization from phenylamine. Okay, they have to react with HNO2 and HCl. And this HNO2, okay, cannot be prepared directly. So you need to have NaNO2 must react with HCl, okay, dilute, and you will get NaCl and HNO2, and this must be less than 10 degrees Celsius. I put 5 degrees Celsius. Yeah. If it is more than 10 degrees Celsius, this one will decompose to become nitrogen gas. We don't want. Yeah, we don't want. So now once you get that, okay, you are going to have, okay, this N2 plus Cl minus. So you see the N and N will join, okay, Cl will join, left with, okay, you left with the hydrogen, 2 hydrogen, 1 hydrogen over here, another hydrogen over here. Okay, so you are going to get, okay, plus, okay, plus there is oxygen over there, so it's going to be 2H2O. Yeah, so it's balanced. Okay, so this is benzene diazonium salt. Okay, benzene diazonium chloride. Okay, so this one, okay, for the production of phenol, okay, you need to have, okay, this one N2Cl. Okay, you react with water, okay, and then you heat up, okay, and you are going to get the phenol. Okay, this is how you get the phenol. Okay, so you will get the nitrogen, okay, and then the OH when, so HCl. Okay, this is how you get phenol. Okay, but do remember this is the first step, okay, in as diazotization. Okay, the first step. So this first step, okay, I will actually select the first step, the one that I'm interested. Copy, and I'll put it here. Okay, now this is the first step. Okay, this is the first step. This is the first step. Okay, so you will go to the second step. Yeah, the second step of the reaction. So the one that is under the reaction of phenol is this one. Okay, where, okay, this phenol, okay, you are going to have, okay, let me, if you have, let's say, for example, you put the N2 plus Cl minus, you react with phenol. This reaction with phenol happens with the presence of sodium hydroxide. Do remember, it must be alkaline condition. Yeah, must be alkaline condition. And phenol now is going to be, it's supposed to be 2,4,6 directing, but because of the space, yeah, because of the restriction, yeah, you are going to activate position number 4. So this one will be activated at this position. If I draw, okay, I can just draw like this, phenol, okay, used to have hydrogen, yeah. Now what happens, okay, this hydrogen is going to be substituted. So the hydrogen came out, okay, substituted by what? Okay, N, okay, this one, okay, that is going to be an electrophile, yeah. So you are going to get, basically this reaction is a electrophilic substitution reaction. Yeah, so you will get this. Yeah, so you have the Cl minus, so you have Cl minus, so basically they are going to give you HCl. Okay, if you want to simplify, okay, this is the azodide, yeah, which is going to be orange in color. Okay, so if you want to simplify this, okay, of course you don't want to write it this way. Yeah, so it's better if you write it this way. You put the OH here, you put nitrogen, double bond N, okay, and then you put, okay, this one. This is going to be, orange dye, okay. So this is going to be one of the reaction, okay, for the phenol. Yeah. So quickly, okay, I have 2 minutes. Quickly, I'll go for number 4, okay, and number 5. Number 4 and 5 is quite simple. Reaction with Br2. This one is going to be aqueous. Okay, bromine water will be decolorized immediately. And then this one, reaction with dilute HNO3. You do not need to have concentrated, no need concentrated H2SO4. Okay, no need concentrated HNO3. Okay, no need to have 55 degrees Celsius. This one is room temperature. Okay, so under the all these condition, okay, this one no need HBr. Okay, so this reaction can happen. Okay, let's say for example phenol. I told you no need to have any help. Okay, they are straight away. They are going to form the reaction. Okay, at position 246. So Br will come here. Br will come here. Br will come over here. So plus HBr. Okay, so you have 3 and this is going to be 3. Okay, this is going to be a white crystalline solid. Okay, white crystalline solid, and you will see your observation is the brown, okay, or the orange, okay, color of the Br2 will be decolorized. Okay, and then with HNO3, yeah. So if you have this, okay, the OH, when you react with the HNO3, okay, directly, okay, you no need to actually balance that. Okay, they don't require. Okay, the OH, okay, OH is going to bring the NO2 there, or it will give you a mixture. Yeah, so OH, okay, at position number 4. Okay, so NO2 here. Okay, and this one, okay, and this one. If you put the reaction under concentrated, if it is concentrated HNO3, and then you can have, okay, the reaction, the OH, okay, so you get NO2, you will get the NO2 here, and you will get NO2 over here. Okay, so this is if you use concentrated HNO3. Yeah, and I think that's it. Yeah, that's it for phenol. Yeah, of course the reaction, yeah, related to phenol, if you compare with naphthol, okay, naphthol, this one is something that you need to also remember. Yeah, I'm not going to go through everything. I'll just go through the important parts. Yeah, so it's 831. So you know that naphthol, okay, is going to be, it will be like this. Okay, this is not one naphthol. Yeah, and this is going to be 2 naphthol. Okay, let's say 1 naphthol and 2 naphthol. Okay, of course, the reaction with sodium, you can do lah. Yeah, the reaction with sodium hydroxide, you can do. Okay, I think the one, our concern is going to be more towards reaction with Br2, for example. Okay, this is 1 naphthol and 2 naphthol. So if you have reaction with Br2, yeah, the Br2, okay, I will just draw here the Br2. Okay, let me select this, okay, copy and paste it, okay, for the reaction with HNO3. Okay, now, so when you react, okay, with Br, okay, with Br2, yeah, the Br2, okay, this is going to activate position, OH is going to activate position 2, 4, 6. So position 2, so Br will come over here. Okay, and okay, you can have another molecule. Okay, it's a mixture. Okay, you will get a mixture OH where the Br, okay, 2, 3, 4. So the Br will come over here. Okay, position number 6 is not available. Okay, position 6 not available. Now, but for, okay, this molecule, okay, it's supposed to activate 2, 4, 6. Okay, 2 is already taken. Okay, 4, okay, 3, 4 supposed to be here. 6 cannot be. This cannot be here. So for this case, okay, the Br will not go over there. Yeah, because okay, it's too cluttered. Okay, so they will come. The Br will go here in between OH and the newly added phenol. the newly added benzene ring. Yeah, so they will come at position number 1 actually. Yeah, the same thing, okay, will apply, okay, when you talk about nitration. Yeah, nitration, okay, you just need to put, okay, the NO2 here, okay, and then you put this one OH NO2 here. Okay, so here, okay, the same. They supposed to activate 246. Okay, so this one not available, not available. 4 supposed to come over here, but this is too cluttered. Okay, so we are going to bring the NO2 here between this and this. Yeah, so these are what I taught you, okay, for the entire chapter. Yeah, so done. Okay, so any